Okay, so happy to see you. Would you go to worksheet 5.5, please? So this week we're pretty much finishing up. We're finishing up chapter 5, and I just wanted to show you business calc. If you float to the bottom of our screen, of course there'll be things. Notice at the very bottom it says, there's a little puzzle piece that says business quiz word problems. So again, I think it's 5 problems, multiple choice or true false. If you're not ready to take it yet, that's fine. I would strongly encourage you though, because it is spring break coming up. Let's have it done before you leave on Friday, spring break, so you can, not have to worry about something afterwards. I totally forgot this stuff, which is possible. So yeah, let's see. Cassie will make it. Kendall will make it. Don't made it. Kate will make it. Cool. So on Schoology, of course, we'll have, starting today, there'll be puzzle or chain links coming down because all of our videos are trying to keep in order. But this is open whenever you're ready to knock it out of the park and do well on it. Let me just take a look at it real quick, make sure we feel comfortable. Let's see, preview, start new attempt. So, and these will be not in the exact order because I think I've randomized the questions as well. So this might not be your question number 1. So you have this type of situation where X is the number of units sold, the number of items to maximize the profit would be 26,800. So you can either give me a true false. On each problem, I tagged in Desmos. If you tag Desmos, it would take you to Desmos if you weren't able to do that. And then if the demand for building a computer is given by this equation and the supply for the computers is given by the other one, where X is the labor cost and Y is the network cost, then what is the market equilibrium? So that one, you are graphing 2 graphs and you're looking where they intersect. So just be aware of the, I have X as the labor cost and Y is the network cost. So those are information in there. Average of the cost function, go ahead and graph this and figure out the minimum value. So it'll probably be a graph that has a downturn at some place in it. And then this is the paper folding situation. So this is very much similar to what we did the other day, and we'll actually do one of the corners or one of the problems like this today as well. So that's something that you would definitely want to graph. And again, it has Desmos available for you on any of the problems. If you have Desmos open once, you don't have to keep reopening it. And then this one, the big key on this one is you have a revenue and a cost equation, and they're saying the profit is revenue minus cost. So what I would do on this problem is make sure you put the top one in parentheses minus the bottom one in parentheses. You graph both of those and you keep them both grouped as parentheses. That would help you quite a bit to do that problem. That's the 5 problems. I think it's worth a total of 15 points, 5 problems. Each problem is 3 points each. Only 1 answer per problem. So make sure sometimes, notice in this one I have the point flipped backwards, 2011, comma 9, or 9, comma 2011. So just realize what you're looking at. Cool? And that should be a pretty easy quiz. But let's take a look at worksheet 5.5. So we talked about the notebook paper last time. And so let's make sure we do this because this will definitely go along with one of the problems. So problem number 1, You have a 3x5 note card, 3" by 5" note card, and what you're basically wanting to do is you're going to cut out the corners, fold up the edges to create basically a box that doesn't have a lid. No lid. That's what you're trying to do with this problem. So just realize if you fold up the corners that if I don't know how big these are, just call it x by x's, x by x squares. So if this whole side was 5 in length, then this little side here would be 5 minus 2x. If this whole side is 3, then this would be 3 minus 2x. So you're trying to find the volume, which would be x times 3 minus 2x and 5 minus 2x. And this would give you a parabola that, or this would give you a third degree polynomial like this. And you're basically looking for this point right here. So if you plug that into Desmos, you're looking for this point right here as your max. And then it's x comma y. So x would be the size of the cut, and y is the maximum volume of that box, or that little container you made. Okay? Pretty straightforward. And then you can easily do that problem once you hit Desmos. If we look at number 2, it says you have 500 feet of fencing and you want to enclose it with a rectangular fence. The garden will extend from the house, so there'll be no fence on the side. So if you had the house, you're basically creating yourself a fenced-in region. You're assuming you could turn this fence at any direction. You don't have to go like 3 feet before it bends or something like that. So right now you have a piece of fence, so your perimeter is 500 feet in length. So you have x values here, you have a y value here as unknowns because it's rectangular. You're not using the side against the house because that's part of the fencing thing. The garden will extend the house. What would need to be the dimensions to give you the largest area? Okay, so if this is x and x, how would I incorporate 500 with x and x for the third side? What do you think? What's x plus x? 2x. And what should I do with the 500? Yeah, subtract it. So 500 minus 2x. So if you do this, this is going to give you a parabola. It looks like this. You're looking for that, which gives you an x and a y value. Your x is the length, and the y is the area. Okay, so that's a classic problem. Of course, you could do it with derivatives, or you could just do it by graphing. It's your choice. Both are going to get you equal thing. Questions about any of those? Feel all right? Okay, I think you can do number 3, same idea with that problem. And I was going to go through some of these and just give you time to work on this in class. Rectangular field, one side of a river along the fence. So number 4, you have this river. And then you have, suppose there's no fence along the river, fence at the opposite of the river costs the fence of the opposite of the river. So fence is going to cost you $20 per foot. And each of the other fences is $5 per foot. So that's what they would charge you to build this fence. And you must contain 45,000 square feet. So your area here is 45,000 square feet. Okay. So let's see, a rectangular field, one side of the river, be fenced. Suppose there's no fence along the river. The fence is the opposite of the river, costs 20 per foot. Each of the other 2 fences, 5 per foot. The field must contain 45,000 square feet. Okay, so this would basically be 5x, this would be 5x, and this would be 20x. In order to get an area, area is equal to length times width, where length doesn't matter if it's shorter or longer than the width. So if area is equal to 5x times 20x. So we know that we want it to be 45,000. So you're going to get that. Okay, so there's two ways you can do this problem. One way is you could say y equals 45,000, and then y equals 5 times 20, 100x squared. And basically this would be a parabola that does this at 45,000, so you have these two. One of them would probably be a negative value, so you can eliminate that. Or you could do 100x squared minus 45,000. And this one you would be looking for the x-intercept. One of the x-intercepts not going to make sense because it's probably be a negative value. The other one makes sense. So that would one of two ways that you could solve that problem. They're both correct. Okay, number 5 is same as the box problem, so you could do that. The hotel room, 230 room hotel is filled when the rate is 50 per day. For each $3 increase, 3 fewer people rented the room. So bouncing up to number 6. So you have 230 rooms that you're hoping to do for 50 per day. So that's kind of the first thing. But you could do this where you could say y equals, if I did 230 minus 3 less, and then 50 plus 3x. So this is your $3 increase. This is fewer people. So if you graph this, this is going to be a parabola. It looks like this. You're looking for the vertex where x is a value. So you'd have rooms and then max money. Okay. A landscape architect plans to enclose 3,000 square foot rectangular region, 25 per foot on 3 sides. Fencing is $10 on the 4th side. Find the minimum cost. So this is similar to the fencing one. So it says that you want a 3,000 square foot garden of some sort. That's supposed to be a rectangle. Let's just pretend. She will use shrubs. So she has plants that she's planting along these sides. And I don't know quite how many. But the red side is going to cost $25 per foot to put these shrubs in. And then the 4th side, that's just going to be like a fence. That's going to cost $10 per foot. Okay, so if you knew you had 3,000 square feet you wanted to get to, you know you have 10x is 1, and then 25, 25, and 25. Is that going to be right? Nope, nope. This should have been multiplied. That's multiplied right there. So that, again, you could graph y equals 3,000, and you can graph y equals 75, 750x squared, where this would be a parabola that does this and this. You're looking for the intersections of the x's. Or you could graph y equals 750x squared minus 3,000 and find the x-intercepts. Okay? And then number 8 is very similar. So I wanted to give you the opportunity to work on those problems. Happy to help you on any of those problems you might have. Don't worry about the very first steps for solving a problem. Don't worry about those, but take the rest of the period, work on those, see what I can help you with. I will be marking that off tomorrow, if that's okay.